So today's video will be on variables on both sides of the equation. So our learning goal for today is by the end of the lesson you'll be able to solve algebraic expressions that have pronumerals on both sides of the equation. Okay, so if there's an equation such as our example here that has pronumerals on both sides, the way we solve that is we collect all our pronumerals to one side by adding or subtracting, so that way we only have variables on the single side, and from there we can solve it. So what do I actually mean by that? Well, we'll use this example. So you can see here we've got 3x plus 4 is equal to 2x take 3. So you can see on our left hand side we have the variable 3x, and on our right hand side we have the variable 2x. Now we can't actually solve for x if we have variables on both sides. So what we need to do is get rid of the variables on one side so that we're only left with one side having variables and one side just having the numerals, and from there we can solve for the variable. Now, to do that, as it says there, we can add or subtract the variables, the terms from one side to the other side. Now, it doesn't really matter which one you add or subtract, it's totally up to you. I always like to subtract, or if it's doing subtraction, I like to subtract the smaller variable. That way I'm not dealing with negative numbers, but it's perfectly correct to subtract either way, and you will get the same answer doing it either way. This is just the way I do it because I prefer to work with with positive numbers, because I do find that students make less mistakes when they're dealing with positive numbers. So the one I'm going to get rid of is the 2x, which is on the right hand side of the equation. And to do that, I'm obviously just going to do the inverse, which is kind of like the opposite. So the opposite of adding 2x is taking 2x. So I'm going to subtract 2x. I'm going to make that a little bit clearer. I'll rub that out. Okay, so I'm going to subtract 2x from both sides. Take 2x, take 2x. So 3x plus 4, take 2x. Well, 3x and 2x are like terms, so I can subtract that. So 3x take 2x is just going to leave me with 1x, so just x. Plus 4, because 4 and 2x are not like terms, so I can't do anything there. And 2x take 3x, take 2x. So 2x take 2x is just going to equal 0, which is going to leave me with that -3. And from there I can solve as I would with a normal equation. So I'm going to do the inverse of plus 4, which is take 4. So I'll take 4 from both sides. So x plus 4 take 4 is just the same as x plus 0, which is just x. And -3 take 4 is the same as adding a negative. So -3 take 4 is going to give me -7. So x is equal to -7. If you'd like to check, you can. Good idea if you're in an exam situation, just to check that you're correct. So 3 times -7 plus 4 is equal to 2 times -7 take 3. So 3 times -7 is going to leave a positive times a negative is going to be a negative. So -21 plus 4 equals 2 times -7 is going to give me -14, take 3. So -21 plus 4 is the same as, it's going to become more positive. So that's going to give me -17 is equal to -14 take 3. So it's going to become more negative. So that's -17. So yes, correct. X is equal to -7. Okay, so we've got two worked examples here which have got the variables on both sides. So 5x take 2 on our left hand side is equal to our right hand side, which is 3x take 4. So again, we've got those variables on both sides. I am going to subtract the smaller number, but you could subtract the 5x if you would like, but I would prefer to work with positives, so I'm going to subtract 3x from both sides. So 5x take 3x is going to leave me with 2x. So 2x take 2 is equal to 3x take 3x is 0, so it's just -4. And then I can just, use my onion method and work backwards to solve for x. So I'm going to do the inverse of the take 2, which is the plus 2. So 2x equals -4 plus 2 is going to give me -2. So divide both sides by 2, so I'm left with x by itself. So 2x divided by 2 is just 1x, and -2 divided by 2, so a positive divided by a negative, a negative divided by a positive is going to give me a negative number, so -1. So x is equal to -1. If we'd like to substitute that x equals -1 back into the equation, we could check that both sides are equal. For b, we've got 6x plus 12 on our left-hand side equaling our right-hand side, which is 8x plus 8. So this time I'm going to subtract the 6x, again because I just don't want to deal with negative numbers. As I said, you could subtract the 8x and it'd still be perfectly correct. So 6x is just 0, plus 12 is just 12. 8x take 6x is going to give me 2x plus 8. So then I could just work my way down, doing the inverse to solve. So I'm going to subtract the 8 from both sides. So 12 take 8 is going to leave me with 4. And 2x plus 8 take 8 is just 2x. And the last step is to divide by 2. So 4 divided by 2 is 2. 2x divided by 2 is just 1x. So x equals 2. Again, substitute back in if you need to, or you should if you're in an exam situation, to check that you're correct. So it's just as easy as that. So when you've got variables on both sides, you're going to collect them to one side of the equation. So you just have to deal with variables on one side, and from there you can just solve using our normal steps, doing the inverse and finding simpler and simpler equivalent equations until you're just left with x equals, or whatever your variable equals.